So since we're drawing the Lewis dot structure of carbon, how do you guys think the electrons will be distributed?
Carbon should have an octet and be the central atom, right?
Yeah, so how many valence electrons does carbon have?
For
4. So if there's 4,
yeah,
would you distribute it like this? Or would you distribute it like this? So is it A or B?
the one on the right.
Okay,
I would say,
and that's
I would
right.
say more like the one on the right.
Yeah, so B would be the answer. And that's because when we're distributing your electrons, you want them to be equal distance. So let's say if we're drawing like
Yeah,
chlorine, you would go, there's 7, 1, 2, 3, 4, 5, 6, 7. It's almost like you're filling your orbitals when you're doing electron configuration. You fill them all through once and then go through again. Okay. So Lewis structure, the octet rule. Haley mentioned this earlier at the beginning, I believe. So the octet rule, every atom you want to achieve 8 valence electrons. And you want to achieve 8 valence electrons because it makes them act like a noble gas. Because it's inert, so it won't react if all of their valence electrons are bonded with something. So in this case, let's say we look at, so chlorine, it has 7 valence electrons. If it bonds with hydrogen, which has 1 to share, you'll actually meet it, and chlorine will act like a noble gas. So chlorine here will act like argon because now you have 18 electrons. So that's what I mean by octet rule. So every atom wants to have all of their electrons outer shell filled.
yeah.
So
However,
how?
excuse me, but with hydrogen, you can only have a duet, right?
Yeah, so there's a duet rule with hydrogen.
Yeah.
So how to draw Lewis structures? First, what you'll do is you'll write the correct skeletal structure for the molecule. So let's say we're doing H2O. You'll have hydrogen and oxygen like that. So you just draw the skeletal structure. That's what I mean. You'll calculate the total number of valence electrons. So go to the periodic table, count how many valence electrons each of the atoms that make up the molecule have, and then that will tell you how many valence electrons you should be counting total at the end of filling everything in. Then you'll distribute them to achieve the octet rule.
Yeah.
So if any atoms lack an octet, H2, I drew H2O wrong. Oh, like that, sorry. I was like, hydrogen has 2 bonds. Okay, so oxygen has 2 bonds with hydrogen, with the 2 hydrogens. You'll distribute your valence electrons, and then to meet the octet rule, and if you're lacking any, and what I mean by that is once you do the basics of every single atom has 1 bond. If you're still missing a bond on the central atom, let's say it's carbon. So let's do CO2. CO2. Actually, you'll do this later. So the first problem I'll give you guys 3 minutes to do. That's doable. 3 minutes. Draw the Lewis dot structures for hydrogen, chloride, chlorine, oxygen, and nitrogen. Okay, so you guys have till 7:20. So I'm going to show you guys what I drew. You guys can confirm with me if you guys drew the same thing or something similar. Your electrons can be different sides. So for hydrogen, there's only one valence electron, so I only drew one dot. Chlorine has 7. I went around and then filled it in again. Oxygen, it depends on you. You can draw it like this, or you can draw it like this. Doesn't matter. This just kind of looks more balanced just because the electrons are on opposite ends of each other. And you want to keep this in mind when you're drawing like actual molecule bonds so that your electrons are furthest apart to repel. Then you have nitrogen and it has 5 valence electrons. So I just went through and did that again. Did you guys all get the same answer? Yeah? Okay. Are we okay to go to the next slide? So the next one is a practice one. I'll give you guys 5 minutes if you guys, actually I'll give you guys 3 minutes. Yeah, 3 minutes is fine. Okay, let's start. So Haley volunteered to go over NH3. So if you want, Haley, you can annotate on my screen.
Okay. This isn't gonna look phenomenal, but
Do you want me to draw it in?
here we are.
Okay.
There. There, done.
Okay. So that's how you, did you guys also, I'll also get this structure, this Lewis structure? Yes, okay. So one of the first things, Haley, was one of the first things you did was to add up the valence electrons, right?
Yeah, well, I didn't write it out, but yes, add
Here,
all
I can write it out for you.
of everything. And the thing is, one thing I noticed fairly quickly was that if it's a neutral compound, for the most part, you must have an even number of electrons.
Mm-hmm.
You're either an electron pair or a bond.
Yeah.
Yeah.
So
except for some freakish ones like nitrogen, like laughing gas.
yeah. So
but whatever.
Yeah. With some exceptions, for the most part, like Haley said, you want your electrons to be paired, or if it's only one electron, that means that it typically has a bond with another atom. So here I added up the valence electrons, and that's how you count. So each bond, each bond shown here has 2 electrons. So if you multiply 2 times 3 of the bonds, that's 6 plus 2 more valence electrons. The electron pair.
Oh, and now seems like, yeah. And also, right now seems like 8. A good time to mention that if it were an ion, if it has a negative charge, you add electrons based on the charge. If it's positive, you subtract them.
So it's good that Haley mentions this because in a few more examples, you'll be doing one with a negative charge. So here's the next example. Let me clear all drawings. Okay. So example 3, I'll give you guys 3 minutes again. 7:31 to finish this. If you need more time, let me know. So what is the molecular form of aluminum chloride? So how is it written? The compound. So it's Al.
Cl.
Cl. How many chlorines do you have to balance?
3.
3? Yeah.
I need 3.
So it's Al minus 1. Oh, 3 plus. Plus Cl minus 1. When you cross them, you get AlCl3. Okay, we're good on that. Okay, so how many valence electrons do we have? So aluminum. Chlorine has how many?
We have 24.
So it's 7 times 3. So that's 21. Total is 24. You should have. So when you're drawing it, Al is your central atom. Chlorine, chlorine, chlorine. How many do we put around chlorine? How many electrons do we put? Type it in, or
7. We put
so
7.
so you put 6
Around
because
chlorine?
your seventh one is bonded with aluminum. Right? So there's technically 2 here. So now if we count it, we have 2, 4, 6, 8, 8 for each times 3 is 24. So it's good. And this is your Lewis dot structure for it. Questions? No? Okay.
Yeah, one thing.
Yeah.
One thing.
I don't think you write it correct because
I
the
said-
AL only have 6 1 for the AL.
Yeah,
What
but
was
this is one of the exceptions, right?
Probably you have to put the 2 on the
Yeah. So AL is one of those exceptions. So if you're looking, so if we look at the periodic table, let's go back. So I said that aluminum has a 3+ charge. Remember, so you learned this, like, how do I? So basically you learned the staircase, right? So
No.
that staircase, so this staircase means that, so zinc, Ag has +1 charge. Your zinc has a 2. Your aluminum has a 3. What that means is that it can form 3 bonds. So that's why when we were balancing it, aluminum can only needs 3 chlorines to fulfill its bonds, its valence electron, valence shell. So that's why it isn't necessary to put 2 more electrons here.
No, I said it's
Yeah, so aluminum doesn't need 8.
it's like that. My main is like that, like Cl.
Yeah, you can draw it on top.
Yeah, like here, like 2 and
Yeah.
6, like that, which is like 2 bond. Yeah.
So yeah, so here you don't need a double bond, and that's because Al has a 3+ charge. So it only requires 3 more electrons to be balanced. Yeah, so it's not always true, but aluminum is just one of those exceptions that you have.
Okay.
Yeah, did your professor say that aluminum would have 8? Or-
She didn't mention that, but she
Yeah,
just say every one for the atom we have to a one for the electron.
Yeah,
Oh,
aluminum and transition metals are some exceptions. It just depends on which one you're dealing with.
Okay, thank you.
Yeah. So the next one. So problem 4, I'll give you guys. So how about someone walk me through this? The other Haley or Jacqueline?
I could do it.
Okay, first, yeah.
So first I draw out the 2 C's.
Okay, so carbon and carbon.
And then I draw out the H's next to 1 carbon.
Okay.
And then the 2 other on the other side.
Okay.
And then I connect the 2 carbons together with 1 bond.
Okay.
And then I add 2 electron pairs to each carbon.
So let's look at this. So let's tally up our valence electrons. So carbon, there's 2 of them. So it's 4 electrons times 2 is 8. Hydrogen is 1
Mhm.
times 4 equals to 4 electrons. So then you have 12.
Yeah.
You want 12 valence electrons total. So let's add up how many we have here. So we have 2, 4, 6, 8, 10, 12. But does this look right bond-wise?
No.
Would make the middle bond double bond.
Yeah. So this is what. So if when we said earlier, if once you fill those in, if you still have spare bonds, so then it would make, so you would form a double bond. So if you add it up now again, you have 2, 4, 6, 8, 10, 12.
Mm.
So earlier we had 14. 2, 4,
Yeah.
6, 8, 10, 12, 14.
Mm.
So this double bond makes sense. Did everyone else get the same answer?
Yeah.
Yeah.
May
So
I mention something?
yeah.
Yeah, I was going to say that yeah, with the nice thing about hydrocarbons is that if fully saturated, you will use all the electrons and there will be no lone pairs and only single bonds. If
Okay, that's a little further than what they need to know sometimes. In some cases for some classes.
Okay.
But
just trying to be more specific.
It's okay. It's really, it's good. So for this, just make sure again to double check how many valence electrons you guys have total that you want to account for. Okay, so the next one, draw the Lewis structure of cyanide. And I think I'll leave the next 2. We can add them to be your challenge questions, okay? So we can go to bond polarity. So I'll give you guys, how about, okay, we'll just do cyanide together. We'll do the next 2 as challenge, okay? But I want to go over finish bond polarity with you guys. So with cyanide, which is Cn minus, carbon is 4 valence electrons. That's the first thing we'll do. Is nitrogen has a negative charge on it. What does a negative charge mean? It means it has an extra electron. So it only has a -1 charge. So nitrogen on its own typically has 5 electrons. So if you add 1 more electron, you'll see, actually I'll write it like this. If you add 1 more electron, you'll have a total of 10 electrons. So with that 10 electron, you're going to write carbon and nitrogen. And then you'll draw 1 bond. Let's see. Carbon has 4, right? So it can form another 3 bonds if necessary. And nitrogen can form 1 more, has a negative charge, right? So let's draw nitrogen alone. Nitrogen looks like this. 5. So it can form 3 more bonds. So if nitrogen can form 3 more bonds and carbon can form 3 more bonds, you guys would start forming a double bond. You can erase 1. And now you can form a triple bond. Like that. You also want to make sure that you have equal amounts. So 2, 4, 6, you still have 4 more electrons. You can distribute them like this, where carbon has 2 and nitrogen has 2. So the formal charge, would be 0, but the negative overall would be on the bracket. That's what I forgot.
I know. I just mean in
Yeah.
terms of form of charge, this time the
Mhm.
carbon.
Oh, you're breaking, Haley.
Okay.
Okay.
Just checking.
Yeah. Let's move on, and I'll
Okay,
come
okay.
back to the last two of these. We're going to skip 6 and 7. I'll just add them to your challenge questions because I want to go over bond polarity. So bond polarity. This is when we're going over the electronegativity of between two bonding atoms. So you have 3 types of bonds. You have your non-polar covalent bond, and it's when your electrons are equally shared. So typically you'll see them with diatomics like CO2, as well as hydrocarbons, CH4. Now, and then you have your polar covalent bonds, which is electrons are shared unequally between 2 atoms. So some examples would be HF as well as H2O, where the oxygen has most of the electrons. Then you have your ionic bonds, which are electrons are completely transferred to an atom. Examples are sodium chloride as well as MgO. So here's a table. I would say screenshot it if you guys don't have one similar. Here's the trend. You'll see electronegativity increases as you go to the right. And it increases going up. That's why we have an arrow showing a decrease going down. Increases like this and to the right. Decreases this way. So screenshot this. You'll need it for the following. Sorry. So I'm going to show you guys how to calculate the differences in electronegativity. So when you're calculating differences in electronegativity, the example I have for you is sodium chloride. What you'll do is you'll look at the electronegativity table that I provided you guys with. And for calculating difference, you're subtracting the chlorine from the sodium. So on the table, it's 3.0 for chlorine and 0.9 for sodium. And when you take the difference, it's 2.1. Looking at this table right here, there's a range. So since 2.1, it falls into this range right here, so it's ionic. If it fell from 1.9 to 0.5, it would be polar covalent. 0.4 and under would be non-polar covalent. Okay. So the next thing we'll do is how to identify a partial positive and partial negative. They're denoted as partial positive, partial negative. So HCl, which one do you guys would think would be the negative charge? Think of their plus and negative charges that we saw earlier on the periodic table. Hydrogen would be a partial positive, has a +1 charge, if you think about it. Chlorine is partial negative. So it goes like this when you draw your arrow. So the more electronegative an atom is, the more attraction for the electrons. So most of your electrons are going to chlorine. So it'd be a polar covalent bond. So here's problem 1. I'll give you guys 5 minutes to do this. Okay. So anyone can go one by one telling me what you guys got. So for number 1, Jacqueline, can you tell me what you got for number 1?
Yeah, it's polar.
So number one, if we look at the example earlier, it's actually ionic. So chlorine, it gets most of the electrons. So that's why it's ionic. Number two, Haley. Either Haley. Whoever
Yeah.
answers.
Okay. So.
Yeah.
Okay. So I'm here already. The second one, I knew that the difference between carbon and hydrogen is pretty small, so it can be considered non-polar.
Yeah. So I'll just draw it out.
And then, yeah, between carbon and hydrogen, it's polar covalent.
Yes. So
And
these
same thing
two.
with oxygen and hydrogen.
These two are polar covalent. This is non-polar. So with the carbon and hydrogens, I want you guys to think of hydrocarbons. Hydrocarbons are not polar, so they're not. So that's why it's non-polar. But with carbon and oxygen and hydrogen, your electrons are being shared. And oxygen is getting most of the electrons. And oxygen is also getting most of the electrons based off of their electronegativity charges too. So the smaller they are, or the larger they are, the more electronegative it is. Okay, so O2, Cindy, can you tell me what you got? You can type in the chat or respond. Or Natalie? Okay, let's see. Okay, so O2 is one of your diatomics. It's similar to Cl2. So earlier we said Cl2 is nonpolar. It's a nonpolar covalent bond. And that's, again, because your electrons are being shared equally. There's no unequal sharing. So oxygen and oxygen are sharing electrons equally between each other. It can be double bond or single, it depends. So BaSO4, Haley, what did you get? Or someone responded.
Is it ionic?
So BaSO4 is actually polar covalent.
We okay, and from between barium and salt and the ion, I don't think so.
Yeah, so SO4 is treated like an ion. It is an ion. So 2 minus charge.
Yeah, but what? Yeah, but what about between the metal and the ion?
So between the
Ionic.
metal and the ion, what was it, Haley?
Ionic, right?
Yeah. When you're drawing it out. Yeah, let me see. Yeah. It would be ionic, actually. Sorry. So my bad, guys. Okay. So we're just going to move on now to the challenge problems. So that was it. I'm going to show it to you guys. Take a screenshot, or it'll actually show up in the recording. So this is the first list. So using the electronegativity differences earlier too. For the next one, I want you to draw the partial positive and partial negative charges for these compounds. except for the polyatomic ions. You guys don't have to worry about that one. This is challenge problem 1. Challenge problem 2 is calculating the differences in electronegativity and identifying what type of bond exists between the atoms. So identify ionic, polar covalent, or non-polar covalent.